Okay, so let's talk about reverse nodes in K group. So you are given a linked list and reverse the nodes of the linked list K at a time and return its modifier list. So the idea is that you need the reverse function, and when you traverse to K length, you need to reverse everything before it, right? So you can still continuously afterward, but the problem is if you start from the beginning again, then that will cause a lot of problems. So you need to continuous after you reverse part of it. So I have a helper function called reverse, and reverse is pretty standard. So if you didn't know how to do the reverse function, I probably have it, but I probably don't have it for the video. So I'm gonna write again. So I explain again. So pre equal to no, and current equal to a, and next equal to a at first. So the idea is that I have a list node A and list node B. So so this is my A, and this is my B. So it's somehow actually okay. So this is the K length, right? So when I know this is the K length, I know I should reverse the entire node, right? So 3 has to go first, 2 remain the same, 1 has to replace, right? So the arrow is actually changing. So okay, imagine you are not moving. So you actually just change the arrow from right to left to right, right? So what happened to 1? Your 1 pointer is actually pointed here, and you already modified this, right? So this will become your head. This makes sense, right? So keep this logic and you do it recursively. Then when you return the head. So that would be easy peasy, right? And let's just keep going. How do I do it? So current is not equal to B, and next is equal to current.next first, and next current.next is equal to pre is equal to current is equal to next. It's actually how you actually reverse. So you just return pre. So back to the diagram, you reverse. So this becomes your head, which is your pre, right? And 1 is actually keep point to the next one already. So I'm not going to explain this, but let's focus on how do I actually do the reverse group. So if head equal to no, it just return no. And I do have list node A and list node B. So A equal to B equal to head first. So I do have to know my length of K, right? So if this is good, so my B is actually the end of the K length, right? So B equal to B dot next. But before it, if B equal to no, if I traverse to some point where B is equal to no, for example, K equal to 3 right here. So I don't have to actually reverse everything at the end, right? Because the remaining nodes are 2 and the minimum, the K value is 3, so it's less than the K. So if B is equal to no, I just return head. So I should know where should I stop, right? So I do have the new head new head equal to. So if I already know where should I have to reverse, then reverse the A.next. So back to the diagram. So I already know that I need to okay, here's my mouse. So I need to know 1, 2, and 3 has to be reversed, right? So when I reverse, my 1 next pointer is already pointed at 4, right? Which is not. Why? Because I need to say A.next. This is how you actually point. So I will initially set to the no, right? This become my new head, right? But I have to point this to the next one. So A.next. It was initially A, right? No problem, right? This is A. This is B, right? So just making sure you know the idea. So A equal to what? You have to do the rest of it. So starting from B to K. And since we don't know the length of the linked list, we can just put K over here. If it hit no, just return. So if that is the case, then you just return new head, and that would be the entire solution. So let's just run it and see if I have error or not. So no problem, right? Pretty good, standard, easy. So let's talk about time and space. For the time, you traverse every single element once, right? You reverse and you skip, right? I mean, let's not worry about this because it's all of k, and you didn't actually have a function inside it, so let's not worry about it. And how about space complexity? You do have the pre-current next every single time you reverse. So you imagine your k is equal to 1. So you create 3 of this node every single time. And also this, right? And I would say the space complexity for the worst case is all of n. And time is as well all of n. And that would be the solution. And the question is hard, but if you know the logic, and that would be easy. And good luck.